Okay, this is your lesson from section 15.3, finding cube roots. And you're going to find that this lesson has a lot of similarities to 15.1, where you learn square roots. So really, obviously, the main difference is this is a cube root versus in 15.1, it was a square root. So one of your key concepts that could be a really helpful shortcut is that you learn that cubing a number and finding the cubed root of a number undo each other. All right, so that's just like what we learned with solving square roots. Anytime I see a number and I'm taking the square root of that number, but then I immediately turn around and square it, those operations cancel each other out. So just like we memorize perfect squares, we can also memorize perfect cubes. And this is very helpful because, again, we don't have a calculator option to take a square root or a cube root for us. So if we have a good chunk of them memorized, we can just draw from our memory. Now, just like we learned with the upside-down division for square roots, we can also do upside-down division for cube roots if we don't know what the cube root of a number is. But again, that's going to take quite a bit of time versus just having it memorized. So let's talk about our perfect cubes. We have 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. And the cube root of these numbers, just like we did our perfect squares, is a number that can be multiplied by itself 3 times to equal that number. So obviously the cube root of 1 is 1. The cube root of 8 is 2. 27 is 3. 64, 4. 125 is 5. 216 is 6. 343 is 7. 512 is 8. 729 is 9. And 1000 is 10. Those are the cube roots. Multiplied by themselves 3 times equal the perfect cube number. So again, just having that memorized saves us quite a bit of work. So in example 1, we're finding the cube root. This is pretty helpful when we have it memorized. If we don't, you'll have to wait till the last example for me to show you how to find the cube root by hand. So according to the list that we just went through, we know that the cubed root of 8 is 2. So we can box that in. What we see that's different about number 2 is now we're trying to find the cubed root of negative 27. So let me just show you how that breaks down. Negative 3 times negative 3 times negative 3, okay? We know that our even-odd rule says when we multiply 3 negatives, that's an odd number of negatives, which means it's a negative answer. So that's how we get the negative 27. So when I'm trying to find the cube root of negative 27, my answer is negative 3. Okay, now this work will not be required on a quiz or a test because I would want you to have it memorized. Okay, so the cube root of 1 over 64, if you remember back to square roots with fractions, this means the cubed root of your numerator over the cubed root of your denominator. It's important that you understand that it's the cubed root of both of them. So you just take the cubed root of both and you make sure that it's reduced. Check for any signs before the original radical, which there's no positive, negative, or just a negative. So I know my answer is 1/4. All right, so we're just evaluating cube roots here. All right, so in example 2, now we have expressions, which means multiplication, division, addition, subtraction is getting pulled into the mix. So look at this first one, but I don't see an operation. All right, but if you remember back to 15.1, we learned that if there's no sign between a number and a radical, that means multiplication. So this is 2 times, now the cubed root of 216. And again, this is something that hopefully you can memorize and do it quickly, and it'll save you work in the long run. The cube root of 216 is 6. Because it's negative, it would be negative 6. And then we just do the multiplication. 2 times negative 6 is negative 12. All right, now we come to the next problem. Okay, and in the first slide on some important information, we talked about the fact that taking the cubed root of a number and cubing a number actually undo each other. And that's exactly what we see happening to 125. We're not only taking the cube root, but we're also turning around and cubing it. These operations cancel each other out. If you can recognize that, you know your answer is 125, and you're done. If you don't recognize that, you would solve it. The cube root of 125 is 5, and 5 to the third power goes back to 125. Either way, you're going to get the right answer. It's just the first way, if you recognize the inverses, then it'll save you some work. Okay, so more evaluating expressions. And again, order of operations definitely comes into play here. So we have 18 minus 4 times the cube root of 8. Would I do 18 minus 4 first? No, don't do that first. I do my multiplication. The cube root of 8 is 2. So 4 times 2 is 8. And then I do my subtraction to get 10. All right? So order of operations is critical. On a problem like this, it would definitely lead you to the wrong answer if you solve out of order. All right, now let's look at the next one. Okay, again, if you catch the inverses, makes this really simple. If I'm taking the cubed root of the same number that I'm also cubing, it cancels out. So now I don't have to take the cube root or do any type of exponents. They cancel out, and I just bring down negative 64 plus 43. And when I take the difference, I get negative 21. All right, so just evaluating expressions and making sure we follow order of operations. In example 3, I'm solving equations involving square root, or cube roots, So again, very similar to square roots, except now it's a cubed root. So if I need to undo an exponent of 3, I will take the cubed root. Okay, again, they undo each other, so they would cancel each other out. But whatever I do to one side, I must do to the other side. So x equals 6. If you remember back to 15.1, when we got to this part of our answer, we said it could be positive and negative. But that's not the case with x to the third power or with cubes, because if I tried to make the negative work, negative 6 times negative 6 times negative 6, that's 3 negatives. It would make negative 216. So my answer is only positive, okay? It's not going to be the positive negative like we saw when we were solving equations with square roots, all right? So it's just really important that you remember the differences there. All right, in this last problem, we see a fraction connected to our variable. We treat this the same way that we've treated them before we had exponents involved. To get rid of negative 1/4, I have to flip the fraction, make sure if it's negative, I've got to keep it negative, and multiply. Okay, so if I multiply the left side by negative 4, I have to multiply the right side by negative 4. So I have n to the third equals negative 8. All right, now I'm ready to take the cubed root. Make sure you put that little 3 up there in the index. The cubed root of negative 8. So now that it's negative 8, what do you think is going to be different in your answer? It's got to be negative 2, right? Because negative 2 times negative 2 times negative 2 would give me the negative 8. So that would be my answer. Okay, so just more practice now solving equations with cube roots. Just want you to pause for a minute and see if you can work through, especially the first one, first equation solving for b, and possibly even the second equation. Okay, so on the first equation, these are 2 steps, okay? So remember what we learned with solving square root equations. We always do the root last, okay? So we need to get everything else to the other side first. So we would divide by 3. We get b to the 3rd power equals 343. All right, so now that I have nothing else except my exponent left, now I know it's time to take the cube root of both sides, and b equals 7. All right, now in this one, it's, a little weird because it's kind of written backwards. Remember, if you don't like that, you can always rewrite the equation as long as you keep this together on one side and this together on the other side. All right, it's not necessary, but you can if you want. So just remember, we always do our addition and subtraction first. Okay, so we're going to subtract 8 to the other side. We get 25 equals negative 1/5 m to the 3rd. All right, does anybody remember, how do I get rid of negative 1/5? We just did one of these in the last slide. We're going to multiply it by negative 5 over 1. So multiply this side by negative 5. And we get negative 125 equals m to the 3rd. All right, so now all I have left is my exponent. So I want to take the cube root. Now what do you think? Is your answer going to be 5 or negative 5? All right, it's definitely negative 5 because of the negative 125. All right, so just pay attention to those signs. With cube root, your answer will either be positive or negative. It will never be both. All right, so last question we need to address. What happens if I give you a problem where you have to find the cube root and it's not in those first 10? It's just a really big one. Or maybe it is a cube root of one that you should have memorized, but you can't quite remember it. So there's a method. It's upside down division. The same method that we used for square roots, except just one small difference. So we still want to, and here's the number 1 rule for upside down division, just as a reminder, we must divide by a prime number. And again, we're typically only dealing with the first 5 prime numbers, 2, 3, 5, 7, and 11. So we look at 1728, and we know that 2 is divisible. We always want to start with the smallest prime number. We divide 1728 by 2. 1728 divided by 2 is 864. So now we're going to divide it by 2 again. 432. And again, because as long as these are even numbers, I know they're divisible by 2. 216. Divide by 2 again. 108. 54. And 27. Okay, so now 27 is divisible by 3. And remember, once we get to a prime number at the bottom, we know that we're done with the upside down division. So at this point with square roots, we would look for pairs of 2. Because it's a cubed root, now I look for pairs of 3. So I have 3 2's, so I know 2 is a factor in my cube root. Okay, now I got another set of 3 2's. And I have a set of 3 3's. So 2 times 2 is 4, and 4 times 3 is 12. So I know that the cubed root of 1728 is 12. And again, you can do this method with any number that you're finding the cube root. So even if it's one that you should have memorized but you can't remember, you can do your upside down division. And that's what you're going to have to do because you cannot use a calculator to find the cube root. All right, so now let's look at 3375. Now, I know it's divisible by 5 for sure. And if you start with a 5, you should still be okay. But do you know the trick to figure out if it's divisible by 3? All right, you take each digit, 3 plus 3 plus 7 plus 5, and you add all your digits together. 3 plus 3 is 6, 6 plus 7 is 13, 13 plus 5 is 18. If the sum of your digits is divisible by 3, then you know that number is divisible by 3. All right, it just makes it easier if we start with the smallest prime number that it's divisible by. All right, so 3 goes into 3375 1,125 times. Okay, so 1 plus 1 is 2, plus 2 is 4, plus 5 is 9. So I know it's divisible again. Divide by 3 is 375. It's divisible again. Now I get 125. This is not divisible by 3, but I know it's divisible by 5. 25 and 5 again. So again, to find the cubed root, I need sets of 3 prime numbers. So I know I've got a set of 3, write it once, and I have a set of 5, and I write it once. 3 times 5 is 15, so the cubed root of 3,375 is 15. Okay, so again, we only want to use this method when we absolutely have to. The more we can have memorized, the better, and just the easier it will be for us. Okay, and looks like that's everything we need to know for 15.3.